the focus in this session, as I mentioned before, is to try to understand, are there, from the conversations we heard, and this is just a small representation of the work that is being done out there, but is there anything that is emerging as a best practice that we should start to bring to the surface and share with the community? Do we need to do more experimentation? For instance, the work that Rich and John mentioned, they are doing some benchmarking. Is this a value for the community to go and more extensively into that space? Should we do more benchmarking? We heard anything, like is a bit disconcerting in a way, because we heard anything from metadata is the key thing to it's really about the services and use APIs to like don't optimize anything. So where are we?
You told me to give that talk.
Well, it's important, right? And we heard it. Gregor mentioned that as well, right? If we do the right APIs and the right service, we don't need to worry so much about the data. So are we seeing any trends here that are really helping us move forward? And so I'm just going to open the floor. And before that, I'm going to give a few minutes for people to just read through some of the questions. These are just some conversation starters. So we don't have any prescriptive direction for this session, apart from letting you all express your thoughts, and we're going to be gathering that. The only other thing I would like to mention is that, so we've been having a lot of conversation with Jeff DLB at NCAR and also with Annie from ESIP about this idea that there's some benefit in following this session. And since we're trying to do this on a yearly basis, would it be helpful for us to document what's emerging each year and what's the status of the landscape, and write some kind of a white paper? And so whatever comes out of this conversation might be something that can feed into that document. Okay, so I'm going to give you a few minutes. Please, if you cannot read, let us know. I guess maybe we can increase the font or something. And then we'll just maybe start going through the list just as a starter, but feel free to add some more questions to the list. Look at my notebook.
No.
I don't know if we're talking now or reading. But... We're reading.
Let me just put
That's probably.
I was just wondering if we could put out maybe it would be easier instead of just. You guys can start chatting.
All right, I'm gonna take. Can we start talking?
Rich is dying. Not okay.
I am totally. Yeah. Hey, James. I was gonna. I just wanted to kind of fess up on the I read that one about getting your data into the cloud and actually kind of following Joe's thing. It's not always easy. Like I think I mentioned that you can just say OpenMF dataset in Xarray and read a bunch of netcdf files and just write ZAR. And well, in practice, when I do that, I fire up my Dask cluster and all the Dask workers start reading data, but they're reading data faster than they're writing data, and they slowly run out of memory, and then then my run crashes. So then I have to find a bigger machine with more memory, or I have to actually force Dask to do the right thing. It's not really as easy as a 1-line, 2-line thing. So I definitely think there's some opportunity for us to figure out like best practices somewhere, write a bit of code or something to, or maybe Dan's already got it, I don't know. But you know, to actually make that experience of doing this data conversion better. It's not that complicated. That's what's so frustrating. It's not that hard, right? You know, you would know how you would write it, but you know, we don't have it, I don't think. And I think I've heard a lot of people hitting this thing. And so I said back, you know, room conversations about how did you do that? Like, how did Anderson do that, you know, out at NCAR? So anyway, that's one thing that I think we could work on.
So, I mean, is this a focus on data writers? I mean, I think most of the time when people talk, they talk about showing tools that are reading the data, right? Because that's like the one-to-many part. Whereas I think the community of users that need tools that write large amounts of data are probably smaller, right? Than the community that need tools to read a large amount of data.
This is just for getting your data. But this is how you know, getting your data. Yes, exactly. Getting your data to the cloud, and it's not. And often you want to re-chunk in there too. And that's the thing that, you know. But conceptually, it's not that hard. But just like general purpose schedulers like Dask, you know, don't figure it out on their own all the time.
While we're confessing, I wanted to do one quick one. Something I didn't get to talk about in the talk. So I showed the example of using SAP Fetch to then pull down the Ngorongoro crater imagery, both from Landsat and Sentinel. So the stack piece gives you everything you need to be able to find that data and get to it. The key piece to making those kinds of things work is that data that it was hitting was organized for use. I'm trying to avoid cloud optimized, but it was organized, it was broken out by bands. It was broken out in a format that GDAL could hit with the HTTP driver and get to it directly. And so if you dig into like that, it's a one-liner that you can run, and the data reduction from what you have to actually, like what you end up with is this, you know, nice subset with a GeoJSON polygon with just the layers you want and just the bands you want. It looks beautiful to demo, but it only works because the that kind of optimized access.
Yeah, so I think there's one of the questions that is up there, and then this reminds me of a question that Hong I actually had for you, is at least the last time I checked in on this, the definition of analysis ready data wasn't settled yet. And I've never thought of that as a conversation related to formats, right? Like those things have always been two separate things in my head, right? Like analysis ready data was sort of about the data, and then the format is the container in which that data resides, right? That's just me. It's the way that I thought of this. But should that be the case, right? Because you can do a whole lot of work to get something into an analysis ready data format, and then you can make some really poor choices about what format you put that data in, right? Like there are a number, as we saw, I think there are a number of good choices for formats. There are also a number of very poor choices that you can make. And so all the work that you put into making an analysis ready fall by the wayside because you don't have a way to let anyone get it, right? And I think this goes to something Greg has said earlier. So I guess my open question there, if anyone wants to sort of to talk about that piece, is should the format be considered a part of the ARD discussion, right? And then just somewhat related, so Hong, I had a question for you. When you do the transpose, right? Because I think this is very interesting, because one of the things that we see a lot is we'll work with somebody to make a whole bunch of data available through the public data set program, and then they will immediately say, that's great, I want it to be in the opposite way, right? And so we say, well, okay, sorry, that's probably not going to happen right away. But you're storing a transpose of the data, right? Or you can store a transpose of the data. I assume that's also coming, like there's no magic here, right? I assume that's coming along with like a 2x increase in the storage for any given data product, right? Okay. Oh, I don't know. Sorry, I shouldn't have asked you a direct question without the mic. Sorry, yeah, can you get Hong the mic real quick? Sorry, up here. Yeah, I'm sorry. I recognize that you put up your hands. I'm also. Yeah, so I'm also trying to moderate. So I'm happy to get to your questions in 1 second. I think I'd just like to get the question answered from Hong right here in the front real quick, and then I'll go to you for the questions. Thank you.
Yes, the transpose does take space to get the speed, but I didn't spend more time on the compression part. Like we support many type of compressions, and especially for kind of scientific data, we have lurk limited error rust encoding, compression, which like we compress, you know that what the error, you can control the error while you encode. Say, I want to have my accuracy to be 2 decimal place or 1 decimal place. So you can control that.
Yeah.
But in terms of the storage, yes, we use storage by performance. Another point that on the ARD thing that, ARD is, so different formats give you different performance, but the analysis ready data has other aspect, which is like, could like cloud removed, and then the pixel value is not radiance, it is surface reflectance, so that you can do analysis reliably, like, vegetation index and things like that. So it has its value.
Yeah, cool, thank you. The question, please.
Yeah, and so I'm not trying to be out of order, so tell me if you don't. I was really going to ask all of you that have been working so much on the data optimization part, if you have lessons learned or thoughts on then the usage of the cloud from a science standpoint, if that makes sense. Because obviously the data needs to be optimized and so on, but I know we're working with several of you I'm from University of Alabama, Huntsville, I'm Sarah Graves. And we run the Global Hydrology Resource DAC. And so we're trying to be the guinea pig with others in here on taking not just the data in the cloud, but also the data services and then the application and then how do guys do science in the cloud. Also being a professor, I keep thinking, wow, there's some layer in here that we're going to have to sort of educate people, because you've got the developers and the scientists that want to do things like they've always done. You've got the excellent cloud, all of the things, the monitoring and all of those kinds of things. So just this talk in the session before made me think, the data optimization is so important. And then how do we optimize all of the other layers? So anyway, it's just saying, hey, if any of you have any things as we go forward, ideas, please let us know. Thank you.
No, thank you very much. And I would just, I think I don't know if Amanda's still in here, but there is a good PanGeo sort of workshop just earlier from an education perspective. Like they're a fantastic group to talk to. So there's a number of folks involved in that. And I think Dan mentioned PanGeo, I think potentially Rich mentioned PanGeo. And then Amanda, she's from University of Washington. So there's a number of groups that are certainly working on that from an education perspective as well.
So thank you. I'm sorry to push into this conversation, but there's a couple of questions I had for some of the presenters earlier. I think one of the key things is when you present the data, in ZAR or other ways, sometimes what you're presenting is just essentially the engineering, the scaled integers that the scientists have produced. And what the scientists really want are, the data engineering units. So they want to apply a scale factor and offset, perhaps, scale it logarithmically and things like that because the data itself is a lot of times not just compressed using JPEG or other compression mechanisms, but you've also scaled it to match the range of an integer or something like that. So I guess the question is, how well do these approaches that you're talking about handle that type of scaling? Is it up to the user to just figure it out? Does the package automatically do that for you? And I guess on the other end, when you're storing the data in these archives, can you actually have that happen automatically? Because there's a large amount of savings in space and things like that when you do that extra scaling step. So, anybody want to respond?
I mean, if you're talking compression through scale factor and add offset, yeah, that can, I mean, like Xarray will automatically do that step, as that's one of the things, you know, that's one of the conventions it understands in the metadata. So, but I mean, there's nothing really, you know, special about ZAR compared to NetCDF or, you know, HDF. I mean, it's just storing data and attributes, and I mean, they can be any kind of data. It's not, you know, any of the types of scientific data types that we have used for the last, I don't know, decades. So I don't know. That wasn't a very good answer. I don't know.
Yeah, I'll give you another not very good answer. My experience with that has been it really isn't at kind of the data, like, to Rich's point, that, you know, that data is being stored, whether it's stored in ZAR or NetCDF or HDF or cloud optimized GeoTIFFs, like you're storing that data. Really, it's moved up in the stack into kind of your Dask Xarray processing pipeline. So as you're pulling that data in, there are transformations potentially being applied. And then with something like Dask, you can actually farm that out and parallelize it. So it's not, in my experience, it has not really been done kind of at the data layer as much as that reading layer that's, or the accessing piece that's been layered on top of it, and then horizontally scaled out from there.
Thanks. Yeah, I had a related question actually. In these conversions to these optimized formats for the cloud, how is the association between the granular level, you know, file metadata and the actual data preserved? So, okay, we talked about scaling, scale factor and offset, but what about things like units, standard names, et cetera, et cetera? So is that, you know, the whole value of the HDF NetCDF data file is the self-describing part? And I'm wondering how that translates into these cloud optimized formats as well.
Yeah, so I think maybe I showed a very, very simple example where there was just a little bit of attribute information there, but you can have as much attribute information in there as you want. And so, you know, just like NetCDF and HDF, you can put arbitrary amounts of extra information into any variable or global attribute. So you don't lose anything in that transformation to ZAR.
I'd actually like to challenge that a little bit, because we're not, when we go from the original, let's say NetCDF or HDF files to a cloud optimized format, we're usually also going to reorganize the data. So, you know, when we're dealing with remote sensing data, especially, we're storing it in this really dysfunctional, thin time sliced form. But to do any kind of time series analysis, we essentially need to aggregate those along the time axis. Now, once we aggregate those along the time axis, all of the individual metadata that were in those original NetCDF or HDF files going into whatever this new cube is, whether it's ZAR or, you know, some stacked GeoTIFF or whatever, how do we preserve that original file level metadata in this completely reorganized, optimized form? Now, regardless of what the actual format is, whether it's in a database or what have you, the fact that we've done a significant reorganization means that we have a metadata reorganization problem that we usually sort of skimmed over. Yes, you would have that in any format. It's the actual form of optimizing the data for analytics that causes that problem, but I think it's still kind of an unsolved problem in this arena. I see Chuck or Charles has a.
I'd say it's important to distinguish between the metadata that rides inside of the file and the metadata that's off on some search tool like GeoPortal or something else that tells you where the file is. If the file changes its name because it's so-and-so.zar and it's in a different location at a different URL, that metadata pointing to it has to change. So it's not just about what's attached to the file directly.
I'm going to go in a slightly different direction. So if there's anybody that wanted to follow up what was going on just now with.
I mean, when we are putting the data on the cloud, we don't move any, so we move all the metadata along with it in the original format at the moment. We are thinking to convert some of these like XMLs to the raster files. We didn't yet follow it through. But generally, I think the rule should be that you are not, I mean, that you take all the metadata and all the data that came along and you put it there. And you, I mean, yeah, when you're changing names, you have to link this back. But generally, we should avoid losing anything. And this is also why I think it doesn't make sense to go too much into the analysis ready data, because whenever you go there, you start losing things.
This has been a great session because I'm not a cloud person. I'm a database person. I mean, if the database happens to be running in a cloud, that's great. But and a lot of what I've heard here is like the 21st century version of the discussions we had back at the beginning of EOS about what the appropriate formats were. So, you know, applying Mark Abbott's law, I can tell what year it is by listening to this discussion, okay, because it has advanced. I mean, we're talking about interactions with formats, with modern programming environments, with optimizing formats to make them servable up over the net. But maybe 20% of what I'm hearing in here is specifically cloud related. A lot of what we're talking about here would apply just as easily if we all had our own computers sitting in our own server rooms and we're serving up data as good, responsible citizens, and which is great. But I think there's architecturally, there's a difference between the kind of things you do to make data processable and presentable and the things you do because they're constraints that are imposed by massively scaled systems over which you have no control, which is what I would call a cloud. Okay, so the kind of things that we're doing in order to make data manageable and servable out of S3 objects are different from the kinds of things that we do to structure data so that it's easy for people to suck over the wire and easy for them to analyze once they get it. So I guess what that's an observation. The question that's lurking in there is, you know, what are the issues that we face that are specifically related to getting our data into the cloud, to basically moving away from having our own machines? I think that's a subset of what we're talking about here, but I think it's important for us to understand what that is, because what I find encouraging is that we are working on and making progress on these problems that are independent of whether the data is in the cloud or not, which I think is good. But I think that there are issues related to, it's kind of apropos what I was talking about with Otis at the break. And he pointed out that, you know, the innards of Google and Amazon and Azure are all very different. You know, and they present you with very different problems if you're trying to move petabytes into those environments. And so I think those are the issues I'd like to hear about, you know, because they're not things that we would do unless we were trying to get stuff into the cloud.
So kind of a piece that fits into that, I think, if I understand what you're saying. So I totally agree with you that what you would do, so for example, like zipping up the data so that you are compressing the data so that you can move it across the wire is kind of what we've had to do. So now we're in a situation where it's easier to move the compute when you're in the cloud world, right? It's easier to move the compute. So now how do we structure and organize the data when we can bring compute to it? Because we want to minimize the transfer of this and be able to use it in place in situ. Where things get weird for me, and Anna has that up on the thing, is the idea of regionality in AWS. And so, because now you end up almost back, like the exact thing we were trying to throw away, this idea of like, how do I move this data quickly across the wire, surfaces again in the cloud. And now we're in the situation where potentially we reorganize and blown this data out to make it easy to access, assuming I can sit right next to it, except I'm not, because this is in Frankfurt and this is in US West. And now I'm not sitting next to either one of them because I need to run in US East. Now, when you talked about the other cloud providers, and I'm, you know, when you look at something like Google's architecture, they have a little bit more of a seamless world there, where that data can move. Once you're inside of GCP, you can move data a little more seamlessly without some of the regionality challenge, like the regionality architecture that AWS has. So I don't have a good answer for you, but I think that's one of those problems where we really want to kind of get away from the idea of how do we compress it to move it around or let people download it, but then we don't have a central region. Joe had asked this question at the Public Sector Summit, that if you could start over, you could probably want to designate here's our geospatial region, and everybody put your stuff there, and that would kind of avoid this problem to a large extent, but we don't have that luxury now. But that would be a case of where that problem, I think, is the cloud is going to introduce a twist on that.
Yeah, so I do want to talk about the regionality thing, but John, I don't know, did you have a sort of comment, or did you want to go a different direction?
Yeah, I think maybe fundamentally for the cloud optimize is that accessing a small portion of data should take less time than accessing all the data. If I have a terabyte file, I want to read like a 116-byte attribute off that, it shouldn't take me exorbitant amount of time. And there are some formats that is the case, right? If I have to download the entire HFI file to extract that one attribute, that's not cloud optimized. So I think that's kind of driving this direction to ZAR and the schema that we use for the HF server and so on.
Cool. If there are no other comments about that, and we can of course come back to it, but I'd be interested in sort of pursuing the regionality question, because I know Chris has come up with this as well. So I mean, Dan already did a good explanation here, but I'll just sort of give a real quick one in my own words as well. And then I'm actually interested to hear from both you as data users, but data providers in the audience. And so the way that this works, and I think this probably applies to other clouds as well, because, okay, the way this works, I'll explain the way that it works in AWS, right? So we have a bunch of regions around the world. You pick a place to put your data in one of those regions, right? If you're using the data in the region, that's good. You're staying on our internal network. If you start using the data outside of the region, you're then going over other optimized connections of ours, but there are potential costs associated with that, both in terms of money if you're egressing out of the region, but also in terms of latency, right? And I think latency you're not going to get away from. So even if you're in sort of a different environment that doesn't necessarily have the financial costs, if you start moving data around the world, there's no magic to get you away from latency costs, right? So if you're running something, yeah, sorry, I'll get to it in 1 second. So you can move the microphone back to him if you would want to. But if you are working on a tool that's trying to access data that lives in different locations around the world, even if there's no financial cost to that, you will still almost certainly have a latency cost to that, right? And so one of the data sets you're accessing might be super quick, and one of the data sets that you're accessing might be super slow, or fast, just not as fast. So I'm interested to know how people think about regionality, and I frame this in the terms of AWS because that's where I work. But you could think of this as if you're accessing any data that's not sitting, if you're trying to access any data with the compute that you're not sitting directly next to, whether it be in a different region in the same cloud, or if it's in a different cloud provider or on-prem somewhere else. Like how do you, like you're trying to process something and a whole bunch of it sitting in an object store that you're computing next to, and some other half of it sitting on an FTP store somewhere else. Like, what does that mean, right? As tool providers, but then also as data providers, like, should this all go in one place? Is that what people would want? I'm just interested to know what this looks like for you all. So, yeah.
So, yes. Actually, this gets to a point that I've been thinking about as well, is that when a lot of people, when they say the cloud, they think of a single cloud. And of course, we know that there are many clouds, and there's sub clouds, and there's private clouds and commercial clouds and so on. And there's been some work within OGC to look at the moving data between the clouds, and how do you do that? But I think there's also needs to be some thought as to how you move the compute to the right place. I mean, kind of optimize your particular problem. You may want to do some compute over here in this cloud, and then move smaller amount of data, but then do some more compute over in this other cloud where this other data set is. So how do you very easily do those types of things to bring all this data together that you might need, as opposed to like moving it all into one cloud and then doing your work, which could be pretty expensive.
Yeah, so I think I probably will share a similar answer to a bunch of folks, but containerization is probably one of the big keys there, right? Most any provider will, of any sort, or local, like you can, if you've got containerized processes, you can run them in a variety of services in a whole bunch of places. So I think that's probably there's probably a lot of other things that you can do, but containerization is probably
yeah, no, certainly that is a real key to the problem. But I think also, how do you make the decision? How do you know what your costs are? How do you kind of on the fly decide, do I want to move my compute there or so on? And for some problems, you can, over time, you can kind of get an optimized solution for, it just takes a while and it takes a lot of thinking to do that. But it's not something you could, every scientist who does this type of processing would have to kind of learn that, learn how to do that and then figure it out and know, what the processes are. So, I mean, I guess one of the questions earlier was, are there some things that we could do in terms of test beds or new approaches? And I think that would be kind of one thing to be thinking about is, as we get these cloud optimized data stores, how do we then make decisions about where to move the computing? How do we decide, when to move the data, when to cache the data, and so on? So.
Anybody?
Yeah, so we've actually been working this problem since like the mid 90s when we were doing near archive data mining. Is how do you know when does it make sense to move the code to the data and when does it make sense to move the data to the code? And now, the cloud regionality has just added to that complexity because now we've got data here and data there. And should we move the code over here or move it over here and then bring that? So, but you could conceive though of probably an artificial intelligence expert system kind of thing that could actually figure that out. That could do a little sample computation over here and figure out, how much data am I going to have to move versus over here, and then come back with a recommendation that would also take into account the cost of moving that data around or doing the compute in the different regions and say, this is the optimal way to get that overall computation done. It wouldn't be easy, but you could conceive of it being done.
And Chris, are you implicitly then sort of calling out the need for some higher level to manage that than like the individual researcher, right? Like that seems like a lot for an individual researcher to do, but if you were sitting within a research institution,
to do it. I want a service to do it for me. So I want a service to, maybe do a little sample computation in each one of those places and then say, okay, I know how long. If you took Dask, for instance, and you added this little expert system above it, it says, hey, before you do your farm out, go out and do some samples and find out how much it costs and how much it takes to get that done, and then come back and do the farm out. So it's like I said, you could conceive of it being done, but it's not an easy job. But then that's why you get the big bucks.
So are you guys doing any of that stuff for NISAR? I mean, for when these big things are coming online, is that the kind of thing that you're?
Actually, not so much for NISAR, because we figured NISAR is so big that the code is definitely going to the data whenever we can do it. But yeah, we are going to do a lot of data reduction, we hope, close to the NISAR data. But again, this is one thing when you've only got one data source to worry about. It's much harder when you start to worry about combining data that are stored in different regions. And that's where, this becomes a more complicated problem.
I think someone mentioned this idea of co-locating related data sets, having all the geospatial data sets in one region. Have we missed the train for that, or should that be reconsidered?
No, I would definitely not say we've missed the train. I mean, I can only speak for myself, but like if it's a thing that we hear from enough customers that they're looking to take advantage of, like we can potentially look at it through the lens of our public data set program. It just potentially means a lot of duplication of storage. So it's sort of a,
I was thinking actually transferring from one region to another region.
So we probably wouldn't want to do that because it would break everyone's code. Or we're going to start charging people for egress when they might not have previously seen egress, or we'll be charging ourselves for egress, or we might not have previously seen egress. So I think we would probably look to duplicate rather than transfer, or at least transfer with very long sort of deprecation times.
Right. At least you're looking at a 2x increase in storage costs, not nx, where n's the number of regions.
Oh, people have asked us to put all the data on all the regions as well. So don't worry. Yeah.
There's a sitting in the public sector summit talk, there was another kind of component to this too, which was a little bit of a political is not the right word, but there is another component to that where, where is ESA going to put Sentinel, and are they comfortable with that living in the US? Where's USGS going to put Landsat? So if USGS migrates this data to the cloud and that's the archive, ignoring backups, but if that's the primary distribution point, is that okay that lives in Frankfurt? And it may not be. And likewise, is ESA going to be okay with putting Sentinel distribution, primary distribution in the US? And you could pick that for each of the geographically distributed regions.
Yeah, and what's been interesting to me, and I think somewhat bears in this conversation, and I'll use an example from the Radian Earth Foundation. Seth Fitzsimmons, who's a fellow at the Radian Earth Foundation, gave a webinar recently. He basically talked about how they, like, due to the nature of the public data set program with data sets that are distributed all over the world, I mean, mostly they're in US or in Frankfurt, but there are some elsewhere. They did a really cool thing, but we sort of forced them to do this really cool thing that added overhead, which is basically they let you make a request for like a tiled piece of imagery. And you make that request into one endpoint that's global. But then what their backend does is figure out where that data set lives in the world, and they have their code put in every region in the world, right? And this is serverless, so it doesn't cost them anything. So we added complexity, but we didn't really add cost, right? And so they have this code duplicated, replicated in all the regions of our infrastructure in the world, and then their system figures out like where that data lives, and it'll run the tiler in the region where the data lives. So the big data pool is in region next to wherever that data lives, and then they're passing back sort of the smaller PNG in this case because they're doing tiling. They're passing back the smaller PNG. So it's a faster experience for the users globally, but we've sort of forced them to do this overhead piece because they're trying to access data sets that live around the world. So it's a cool piece of technology. It's a webinar. If you search for AWS Radian Earth Foundation, you should likely find it. But I don't know that it's the optimal solution. But the piece where it's interesting here is the only reason why this works is because most all those data sets are made available in cloud optimized formats. So they can do those really quick reads for the small chunks of data, right? Obviously, if they had to pull down gigs for every request, it wouldn't be performant at all. So, okay, Chris, you had shook your head vigorously previously. So I'm gonna ask you a question. So I previously said, should the file format be included in the analysis ready data sort of discussion? And you vigorously said no. So.
Right, I vigorously said no because as soon as we even say file format, we're already, discounting all of the possible database forms of storing the data. So to me, I view the analysis ready data aspect as being everything you do with the numbers. Most of that stuff involves some little, usually small change of the number, but it's a change. You're either subsetting it, you're filtering it, you're regridding it, you're reprojecting it. But as soon as you stop changing the numbers and then just reorganize them for your particular form of analytics, that's where I sort of make the break, I think, between analysis ready data, and you can either call it archives of convenience. I've heard Dan call it. I usually call it an analytics optimized data store. But to me, that's where you're just rearranging the numbers. And I see those as being usually different, or I'd like to keep them different because it gives us much more flexibility in how we organize the data after we've made it analysis ready.
I guess I would counter that a bit. I remember one of the data sets, the public data sets program, was this astronomy database where it was stored like a MongoDB dump format. And to use it, all you had to do was create a super large instance, copy all that data, and then start feeding SQL queries. That doesn't really strike me as analysis ready because this person's talking like, took them like, 3 days to set up the server, and it cost tons of money just running the server. So there's not a lot of utility for people who weren't, deeply invested in setting up access to that data.
Yeah, I guess I'll actually mirror that point a little bit, because to me, as a single user, scientific user of data, analysis ready data to me means like I can use GDAL with this data because that's what I understand. Whereas in S3, it might mean a data reorganized in a different, tiling scheme or whatever is useful for pulling out the headers and stuff like that. But like, I might have to download a large set of that data and reorganize it in order to use it in a way I'm comfortable with. So having some clarity on what that means, whether it's cloud analysis ready or like individual object analysis ready, would be kind of interesting to me.
So one of the things about ARD, I mean, to give you an example, because there was a workshop last year about ARD and there was a lot of conversation around an example of those ARD applications, which is harmonizing Landsat data and Sentinel-2 and use them as one data set. It's not going to happen globally, and no one wants to do that and store everything in a third resolution and a scale. But many people are basically interested in having that on demand, and that's one of the things that, for example, Gregor was talking about. If we can have that functionality that I, as a user, go to a dashboard and say, this is my region, this is my time, give me a chunk of data, combine and harmonize Landsat data and Sentinel-2 to this specific resolution. Having those functionality doesn't need to think about the format of the data. It's about how I process the data on the fly to take it to that ARD. The challenge and the opportunity is that ARD is application specific, and we can think about one single ARD format. And we should acknowledge that. It's an opportunity, but we should think about how we can process that on the fly to get it to that application.
I was just going to say that it sounds like a distinction. I mean, I agree with Chris in the fact that, once the numbers are where they're supposed to be, then that's sort of one line in the sand. But then you're talking about, processing ready data, because everybody, GDAL is going to need it one way and some other application is going to need it laid out some other way. And so you've got this notion of when is it optimized for a certain process, and you might have to have, several formats for some easy way to change that. And the easy way to change that is not always easy.
So I guess what I'm hearing here is that, well, first let me make an observation, is the data is always going to be distributed in the file format that it was originally created in. So what it sounds like is that there's often use cases to have the data in another format for analysis ready, process ready, et cetera. And so what I'm wondering if it would be a better idea to either have a copy of that form of the data available alongside the original data, or have it available on the fly through a serverless function or something like that. Does that sound like a possible approach to this?
Yeah, I mean, Greg, I think I'll ask you. I mean, I'm sure there are a bunch of you in the room who have experience doing this, but I mean, I think you've done a lot of your transformation serverlessly, right? Like you run a whole service to sort of do this on the fly for people. So, I mean, I guess some of the question is like, does it work for you? Sort of doing that. So you're trading storage for processing, essentially.
Yeah, and I mean, it's not obviously always the right way, because the more complicated the processing is, if you repeat it many times, it will be more costly than storing it, right? And doing it like on demand, sometimes it might take minutes or hours or days, and people are not willing to wait that long. I don't see the reason why we would need to store the data along the original format if we are not changing anything in the original format, right? Like, for example, Sentinel-1 GRD that we changed from the original format to cloud optimized GeoTIFF. We didn't change anything at all. I mean, you can always go back to the original format. We did this test that actually there were just 2 bits which were different, and we had no idea why these 2 bits are different, but they are useless, it seems. I mean, the point is that when ESA 10 years ago established the format for the Sentinel-1 GRD, they didn't think about clouds because they were at the time they were not relevant, right? And Now, I think that we can simply, if there are some things that we can do easily to correct this, I don't see a reason why not to do that, right?
Thank you. I think that the topic that bears on this is provenance. How do you know it's what was originally provided by whoever the provider was? And that's why I think that this idea of there's going to be a pristine copy that's original is really important. Now, whether it probably is best in the cloud so that anyone can always go back and look, but then you should think about the what I'll call more analysis ready and how you make them. But I disagree with you. I think for provenance purposes, you have to demonstrably be able to demonstrate this is what I got. And if you don't have it, I don't know how you do it.
Yeah,
Super
I think
comment.
Gregor just wanted to respond real quick. Sorry, Rich.
Yeah, I mean, what I heard Gregor say was like, if you're round tripping it though, right? I mean, isn't that what you said? You could go back. Yeah.
I mean, we're probably not I mean, we are too pragmatic for this kind of discussions, but I mean, even European Space Agency, which is in the case of the Sentinel responsible for this, they cannot guarantee for each specific file where it was originated. They originated many times to different ground stations. They lose track of the information between level 1C and level 2A. So I think that as long as you know, I mean, you can demonstrate what you're doing with the change, like converting to cloud optimized GeoTIFF, and if you understand that you're not changing any value, I don't see a reason. And if, for example, this process is open source, which Amazon is demanding in the case of the open public datasets, so that everyone can check it after you, I don't see a point of having a copy of the data just because someone would want to have the original file, which is exactly the same, but the 2 bits.
Magical 2 bits. So I think that some piece of nuance here is that, and we're sort of using the AWS public dataset program, but sort of as a reference point. So some of the data that's made available through the public dataset program is made available from the source agency, right? Some of the data sets are made available in the case of Synergize from a third party that's getting the data from the source, sometimes doing some transformation, then making that data available, right? And so it sort of gets me to a question that I have, which is, like, it seems like there's this implicit assumption that the data is made available in the way that the data is made available, and that will never change. And then if we want to be able to do anything useful with the data, it also needs to be made available in some other format. And we need to get somebody to make that format, right? And like you've heard from a number of people who are doing that work to convert it from the potentially not so useful for analytics data format into that more analytics friendly data format. I guess my question is, why is that the assumption, right? And I think USGS is a good example here. USGS currently makes their data available in GeoTIFFs. They have seen what people have been doing with cloud optimized GeoTIFF. So USGS is in the process of making all their data available as a cloud optimized GeoTIFF. That's not changing anything from their perspective. I mean, they would be the ones that ultimately say this, right? This is the ARIS group. Like they're the ones that are ultimately in charge of making that determination. But, and this is particularly easy for GeoTIFF and cloud optimized GeoTIFF because it's backwards compatible, right? Like we give cloud optimized GeoTIFF a big name and it's done a lot for people, but like it's very few tweaks to get from a GeoTIFF to a cloud optimized GeoTIFF, right? Like it's the same format. You're just basically making sure to put the header information in certain places and doing internal tiling and handling overviews in a certain way. Like it's not like a HDF to ZAR or anything like that, right? Like it's backwards compatible. So this is a particularly easy example, but things don't need to stay the way they are, right? Like, does there need to be this distinction from an archival data set? Like, why can't you archive the data set that's also useful for analysis, right? Like, why do you need, this is part rhetorical, but also part real. So if you're a data provider, please answer. But like, can we not get to the case where the data that the most people want to use is also the data that's being produced coming out of a pipeline right? Why are we forcing somebody to duplicate storage? Why does that need to happen?
So I'll give a good example of this. 20 years ago, we designed the Modus Level 3 products, the gridded products that are used within the Google Earth Engine for a lot of VIs and other things like that. And one of the big decisions the science team had to make at the time was what map projection we use, and we chose sinusoidal grid, which everybody loves to hate. But we would love to do a lat long projection. We'd love to do, have 3 projections, a polar projection. I mean, there's reasons why each of those projections could be useful, but in terms of funding, we have enough money and enough resources to do one. And I think that's maybe an answer to your question. I mean, every 2 years when we have a science, or year and a half, we have a science team meeting, we come back to this projection question. Can we do it better? Can we do it differently? What community want? And in the end, we kind of converge back to where we started. And I think that if it's just a format issue, maybe that's easier. But if you start digging into, a lot of the Landsat data is done at a regional resolutions. That's why data cubes over particular regions work really well, because you can just put it all in the same grid and everything works. But you can't necessarily choose one grid to do global data everywhere. So you have to kind of figure out what you're doing with the gridding and so on.
So Robert had a really good answer, and if I could just generalize that a little bit. And in fact, some of the data products, the level 3 products that you put out in a sinusoidal grid, but there's a so-called CMG version of it, climate model grid. And the reason for that is that there are some users that want that sinusoidal grid, but there are other users whose use cases are more amenable to the climate model grid. And so that comes back to the whole definition of analysis-ready data depends on the analysis you want to do. The same thing goes for an analytics optimized data stores. It depends on the analytics you want to do. And so there's no single answer, which is why we find ourselves needing to store an original version, but then potentially make other versions either on the fly or in some cases pre-made and cached for different user communities.
Yeah, I think maybe there's one aspect of Joe's question that is a bit different, in that you can't make everyone happy all the time, but you can make everyone unhappy. And that's when you're making a stupid decision that requires you to definitely download all the data to do anything. I think you mentioned like a zip versus gzip, right? I don't think there's any advantage to storing files in zip, but if you do, you have to download the entire file to unzip it, and that's kind of silly. So I think there's simple things we can do to make the data more amenable to being accessed in place in the cloud. The other thing is I'd like to point out that, like Kwong, you mentioned regridding the data. That's common to make it more efficient to do time series, but then the cost is you have to pay for twice the storage. And I think in the cloud, since you have the scalable compute, oftentimes you can trade compute off for storage. If you can spin up 100 spot instances and do this on a fly and you get the same result, your costs overall is likely less, right? Because you're paying that 2x storage cost 24/7, you're paying the compute cost just for when you need to do the data.
Yeah, and I think that's what some of what Gregor was getting at too, in a sort of a random access pattern, right? Like if it's a true random access pattern, then maybe you don't need to store everything, right? But another answer that I get a lot, I ask a lot of people, like, what data would you like, and how much of it would you like? And everyone always says, of course, they want it all, and they want it all, right? So there are large scale, some of the data sets lend themselves to large scale data reanalysis that does potentially touch most of the archive. And if that starts happening more than once, then I think you're back to the storage paradigm, right? But it's going to depend from data set to data set for sure. Yeah, and John, I think part of what I was getting at was what you said there, right? Which is, are the data sets that are the base level data sets in those formats, are those the right formats? Or can those have some tweaks to make them most malleable into whatever needs to come after, right? So I 100% agree that like you can't make everyone happy, and like the archives of convenience, like I think they make sense. Especially I'm a big believer in sort of a flipped model where like I don't think it should be on the government agency to necessarily create all of these for people. I'm very much a fan of like, especially if you're a commercial institution, if you have a commercial reason to be sort of requesting data sets in a certain format, like that burden can go on you as the commercial institution, right? And so I very much like the archive and convenience thing. I'm pointing to Dan because I've seen you present on this with some of the SATCAT work, but it's basically like, this is the area I want and this is the format I want it in, and so convert it, right? But the ability to do that is still predicated on the fact that the underlying data is made available in a certain way that makes it easy to convert, right? So I guess part of my question was getting at, are the base level formats that are out there, are they the right level base, the right base level formats to be easily converted into something else, or do they need to be different, right? And I think it's going to depend on data set to data set, but.
I'm pretty sure this is what you meant, but I just wanted to explicitly ask. You mentioned kind of GeoTIFF versus cloud optimized GeoTIFF, and that they're very close. They're very close as far as formats go, right? It's not a big lift to get from to produce a cloud optimized GeoTIFF versus producing a GeoTIFF. But it's not an insignificant hurdle if you have a petabyte of GeoTIFFs and you want to make them cloud optimized GeoTIFFs. Like it's still, unless I'm misunderstanding something, like you would still have to reprocess. Making the jump from a petabyte of GeoTIFFs to a petabyte of cloud optimized GeoTIFFs isn't a big difference between doing that and making a jump to a ZAR, a petabyte of ZARs or anything like
that. Mine was more a cognitive difference.
Okay.
Like I'll just use USGS as an example. For USGS to have to go to their users and say, we're converting from GeoTIFF to cloud optimized GeoTIFF, I don't think anyone's upset. There's always going to be somebody that's upset, but I think there's one person that's upset, and then a whole bunch of people that probably don't care, and then a bunch of people that are happy. If they were to say, we're going from GeoTIFF to ZAR, you'd probably have a lot of unhappy people, right? There'd just be a lot of cognitive dissonance, right, and left. But you're correct.
But ultimately, it has to really kind of go back to the data provider to some extent to like really say, like, look, if you can make this in a format like a cloud optimized, there is a big difference between a provider putting out, take NISAR, putting out 100 and some odd petabytes in GeoTIFFs versus putting out 100 and some odd petabytes in cloud optimized GeoTIFFs. Like there's tremendous value as a data provider to be looking at how do you produce it in a cloud optimized format with minimal disruption.
Yeah, which is easier, I guess, if you make the decision up front. Of course, then a decade from now, we just have this same discussion with some other format. I am cognizant of that, right? I don't pretend that any of this is necessarily new. So, cool. Were there any other questions from the audience, or I can look on the sheet and get another one? Yeah.
Thanks. So we talked a lot, we've been thinking a lot about level 3 products, essentially gridded products. I think there's another paradigm, well, a different paradigm when you start thinking about level 2 products or level 1 products. And that's what I mean is in the original swath format, that the data comes from the satellites or various instruments. Are there things that we should be doing as data providers to make those data more optimized for the cloud? Or I mean, I kind of understand, with the level 3 products, if you change the chunking in such a way that you're doing tiles as opposed to line-oriented chunking, you can gain quite a bit. But I haven't heard of any specific things that we could do with the level 2 data that it would make it easier or more optimized for the cloud, because you just have to run a resampler against it somehow. Has anybody been thinking about this at all?
Yeah,
besides,
and
I think we have actually with our stair project, but I was wondering if
this could be a
which
different
kind of optimizes, you know, it tells you where things are within the level 2 file, but maybe some other people have some ideas.
Yeah, and I may be misinterpreting this, and I'm sadly probably the least earth science savvy person in this room, so somebody yell at me if I start going astray. But and specifically for the Landsat ones, right? Like that is like all of this is around the level 1 data, right? And then potentially level. That's correct. Yeah. Yes. Yeah. I'm not gonna. Sorry.
Related to that, I guess more generally, has it been shown that these cloud optimized storage formats can support the range of spatial data types? So we're talking, you know, swath, gridded data sets, trajectory, profile, point time series type information. So, you know, that covers the suite of observation types in terms of how the spatial sampling happens.
So I think part of, so I think, and this relates to one of the questions that's on here, cloud optimized GeoTIFF is not the answer for everything by any means, right? That's why I think you see things like ZAR, right? Like there's different cloud optimized formats for different types of data sets, right? Like I had mentioned Parquet. There are people that are taking, this is a group out of Cornell, they're taking GRIB data and putting it into Parquet, right? So they can use sort of traditional SQL tools to start analyzing it. That makes sense for tabular data or anything that can be represented as tabular data in somewhat of a reasonable way, right? So I think what we more see, and I think this was Gregor, whose title was basically not one format to rule them all, but a pattern to rule them all, right? And so we've seen different sorts of formats for LiDAR data. This is work that was done by Hobu. It's an entwined point tile format. And so they've got something like 12 trillion points up from the USGS 3-depth program that they put up and converted into a cloud optimized format for there. Is it the right cloud optimized format? I don't know, but it sort of meets the overall mission of minimizing the amount of data you do not want to get to the data that you do want, right? We've seen cloud optimized GeoTIFF. We've seen things like the cloud optimized HDF. We've seen things that are cloud optimized zips and cloud optimized TARs, right? Like you can do a lot with formats that already exist. So I think there's probably more of a paradigm shift than like some new great format. And I think depending on the data type, it'll be a different format.
I actually have a question because we have many users and they also want our software to support swath data. And we actually, we do actually support. And actually, I heard from scientific community, they have different opinion on the way that we support. So I like to actually get your input from. So what we support is that because so my question is like, how do you see the swath data being used or being visualized? Or do you want to see them as points, or do you want to see them as the graded format? So what we support is that we automatically, because these are variables and the dimensions, but these spacing are different, or the points are not regularly spaced. So what we do is that we automatically, user can specify a grid size, can specify an interpolation method. We automatically on fly interpolate as a surface. So this is what we do. You see as a raster.
Yeah, I mean, for the level 2 swath data, it's a different group of users. It's typically the science teams. And their primary interest is in evaluating the quality of the retrieval algorithms. So they're not interested in interpolation. They're interested in evaluating, doing collocations with in situ data, and ensuring that the retrievals match up with the correspond well with the ground truthing. So that's that's the primary, I'd say, use of the level 2 data. It's not so much by the general science community, it's by, these expert users. So, level 3 is a different thing. That's, you broaden the user base there significantly, and there's more applications users for those types of data sets.
Yeah, I think the approach that you're talking about is actually very applicable when you're combining it with other level 3 products or gridded products. So yeah, you need to have that capability to interpolate, but like he just said, it's probably not the only use case. There are other use cases where you actually combine multiple swath data to produce new data. So you would combine like a snow product and swath, and you would combine fire data, and you would combine other information in the swath format. And if you stay in the observed format, you maintain the integrity of the data. It's as it's measured by the spacecraft. So you're not blurring it by doing a resampling or a kriging or other types of operations. But you may want to combine it with gridded data, and eventually, of course, you probably want to produce a gridded product at the end. So there are some scenarios I can think of. It's probably not the more general user, but more the scientific user who's trying to develop a new product, where he's combining multiple instruments or multiple data sets. Some of them in swaths, some of them in grids, some of them in different swaths, and you have this kind of trying to figure out for each location on the ground what is the best answer I can get from those data. So.
Thank you. Does anyone else have anything they'd like to say? I used to be a teacher, so unlike Rich, I can stand here in silence for at least 10 seconds and see if anyone else has anything they'd like to add. Okay, so just one note, and I think we'll discuss next steps. So I think we can get access to everyone who signed up for this session in the Schedule. So if you would like us to send you any of the notes from this, please do that, and then we'll, I guess, collect them afterwards and send you everything. So one of the things that I'm particularly interested in, that the AWS Public Dataset Program came up a couple times. We use that as a way to experiment with different ideas similar to what we've all just been discussing. So I'd be interested to know from the group, are there any sort of particular experiments that would be useful here that we should try and make happen? And just to be very transparent, like we're an infrastructure provider, so we can help potentially provide infrastructure for those experiments. We would need to work with somebody who's the subject matter expert, right? So we would be looking for somebody to work with to sort of bring these experiments to fruition. So that would be the next question. So it's perfectly fine to yell out something that you would like to see experimented with. If it's a different format, if it's a different data set that would represent a different data type, for example, that maybe you're looking to see what a cloud optimized format for that data type would be. But then the next question will be, who can we work with to try and make that happen? And if you don't know, that's fine. It's okay. It's part of my job to go out and find those groups who are interested in doing that. So just sort of at large, are there any sort of experiments that we should try to do for the good of all of us to see how to move this forward?
So I don't have a specific experiment in mind, but I really liked what you were showing, where you were talking about not just how much faster it was going, but what the cost was. And so what I'd like to see is if we do any of these kinds of benchmarks, it'd be nice to also be benchmarking the cost of each one of those runs, in addition to, whatever the speed up is, as a custodian of taxpayer money, et cetera.
Yeah, just ask Gregor. Gregor always shows his bills, so it's. But so Chris, in seriousness, I guess that actually was a serious answer. Gregor does often show his bills in his presentations. I think they were too short this time, so I don't know if you actually showed any of your bills. But how how can we do that? How can we help you get that information? Like what do you think this would look like? Because we have like, there's often groups that do something like this, they're just not often collated, right? So I think I've already heard a couple of times people say like, we've done this and it only cost us a couple dollars, right? I think Synergize had a blog post where they're monitoring 7,000-ish bodies of water globally or something, and it was like at €6 a month or something.
So your talk was one of the first cases where it actually.
Cool. Yeah. In fairness, it was incredibly easy in my case because it's like one number. But I get. Yeah. But I get what you're saying. Okay. Thank you. Damon, is it? I think there's one behind you. If you don't. Oh, sorry, Rich.
Yeah.
Go ahead.
Just back to the multi-region thing, and Chris was sort of saying, hey, it would be great if there was some service that would help figure this out. Something like that would be cool, or like maybe even just this use case that you gave where these guys figured out how to, do this, basically having some parallel processing going on in these different, in these different regions, which is filtering down the data. And I know there was talk at SciPy last week about having DAS clusters running in different regions and stuff like that. So I think that's an area where there could be some cool investments that would pay off big.
Cool. Yeah, I assume the Radian Earth Foundation code is already open source. So that's something to potentially look at. Zach, if you can just make a note, I think we can probably point people, or Anna, we can probably point people to that webinar and the code. That likely could be generalized to include more places as well.
Yeah, I wanted to second and generalize where you were going, where Chris was going with his idea about, the how do we suss out the costs. I mean, that remark you made earlier, Chris, about if I'm about to run a job, is there some way I can send some pings out that sniff out like a small sample of the problem space and say, wow, today it would be better for you to be running over here than over there. I mean, there's so much horse sense right now that goes into structuring problems for the cloud that as an academic, when I go to these presentations, they always end it with, and if you wind up spending $20,000 by mistake, talk to us, we'll wipe your bill out. The assumption being that you're inevitably going to do something like that just because you don't understand all the knobs. I mean, ideally what I'd like is something, if I have a problem that I want to run, it goes into a dashboard, and the dashboard says if you're going to do it with buckets, it's going to cost this much. If you're going to do it with a file system, it's going to be this much. If you spread it across, all these various parameters that I would have some control over, it runs the numbers and says this is the mix that you want to solve it, or this is what these various options are going to cost. Now, obviously, I can't do that because you don't have the understanding of my problem. So the question then is, how do we simplify what is now a very iterative process of me turning my problem description into something that you can cost? And I think if we have the end point of that being that we really do want this dashboard where I bring in a problem, you classify it and say, he's hand waving about finding snow, but what he's really talking about is whomping rasters, and we know how expensive it is to do that. And so we're going to cost it. And we're going to tell him how much it is. If we can get towards something like that, that would be huge in terms of our ability to exploit these resources.
Yeah, so just one caveat. I've seen those same presentations. We do have ways to help you prevent spending that much money. I didn't want to yell up and say it during the presentations, but there are ways that we can help you with that. But the other piece is, and any of the folks that are working on Cumulus, I'd be interested to hear from you. Because I think your point about these all being somewhat different problems does make it very hard to generalize them, right? But for a lot of these, you're trying to process bits, right? Like it's an oversimplification, but a lot of these processes may look the same. So I almost wonder if there was a consistent framework that a lot of people were using, call it Cumulus, it might be something else, maybe PanGeo, right? Like maybe it's PanGeo, or maybe it's something like Cumulus. Do you think that gets us to some way of sort of having more of a framework that we can then say like, okay, you're just trying to run Cumulus on this much data, and 1 unit of your processing would cost you this much. So it's going to cost you X to do the whole thing. Because if it's all just sort of abstract and there's no cohesive framework, then it seems like a very hard problem to tackle, right? But if you're sort of doing this all in a cohesive framework, like a PanGeo or a Cumulus or through a tool like ArcGIS, I wonder if it becomes easier to to try and do this analysis.
So I think the pattern to look at for that might be, the AWS architectural patterns where you can go in and you can say, this is my general class of problem. And you'll basically get okay, you hook this up with this, and then you hook that up to that, and you hook that up to that. If we could do the same thing with science analysis problems and say, if you've got this particular science analysis problem and this particular type of data, then this is the general wiring pattern that you have for that analysis, then we might actually, get in that general direction. And at the same time, we might also have these science analysis patterns that would allow us to realize those systems more cheaply than we do now, where we're kind of, still are, making these artisanal data analysis systems.
I have a somewhat related question about cost. From the point of view of data providers and data consumers, Amazon has a whole different plethora of ways to define bucket policies. You can have request or pays buckets. I guess that's good from a data provider who wants to limit the amount of egress costs they would pay. Then there's infrequent access buckets where even if you're in region, you would still have to pay per amount of data transferred. That seems prohibitive from the data consumer point of view. So I guess the question is there any kind of consensus emerging on what the best way of setting up a bucket that meets the needs of both the providers and consumers of the data?
Yeah, so I believe infrequent access, you do pay an increased cost for request, but you still don't pay egress, I don't believe. That may be incorrect, but I think that's still true. You pay an extra cost for access because you pay less for storage, right? But I don't believe there's any egress cost, right? So if you're making one request for a gigabyte of data, you're not paying for the gig, you're paying an extra fee for the request because you paid less to store it, right? That's the trade-off there. But to answer your question, no, I don't know that there is a defined model amongst groups who have a mandate to publicly share their data, and they're trying to do so through the cloud. I think we'll see some big experiments coming out in the next year or so. And I think something needs to get out there, and then people need to give feedback. We do it a certain way in our public data sets program, but that's an experiment with a very certain purpose, right? Which is not the same necessarily as an agency who has a congressional mandate to share this data long term. That's not necessarily the same as how they would do it. So I think we're going to see some big experiments in this area come out in the next year or so. And then it'll be time for users to use it and for the agencies to sort of own it and then sort of progress from there. But it's not a solved problem yet, I don't think.
So yeah, I had an experiment, I just kind of touched on it earlier, is to start working more with the swath data, the level 1s and level 2 data, and thinking about optimize what it means for that data to be optimized for the clouds. Just a few weeks ago, there's some discussions within NASA about what data sets we should put in the Amazon cloud to kind of make them available to the end users. And I thought that some of the data which I would like to see actually used more in the cloud is actually the level 1 products from Modis, and I'd like to see us enable scientists to use that data and actually generate new products from that radiance data that you get from the spacecraft. And I think there's a lot that can be done, certainly with the level 3 gridded products that we've been producing for many years. We've kind of optimized those for specific use cases and users. But when you get to the level 1 and level 2, I think that's where you're enabling new science to be done so that you can actually advance the science. And I think that if we could figure out ways to allow the scientists to actually use that data it'd be really useful. So that would be an experiment, perhaps. But I guess it's also maybe a challenge, and maybe we're not quite there as a community yet.
Thank you. Is there anything else? We good? Yeah, Annie.
There's a scientist using the data question, and there's also the other bucket of users, app developers, industry, and they were saying that, and it was related to the analysis ready data talk, they're kind of like, for us to make money and innovate, we want something that is proprietary. And so the kind of exciting access to level 1 data is, they kind of said to us, that's really what we want, because we're allowed to create proprietary products on top of it. And that was from kind of the big money reinsurance companies, you know, kind of the not science crowd, but the industry. So just an aside on that. Mm-hmm.
Thank you. Anything else? All right, with that, I will, I guess this is the second part. So thank all the speakers again, and thank all of you who participated and who also listened. Thank you very much. We will, oh yeah, I did early, but sign up if you would like to get any of the notes from this, please sign up to the Schedule. We'll probably do it towards the end of the week, so you've got some time. Thank you.